Good morning, ma'am.
Morning, everyone.
Good morning, ma'am.
Good morning.
Good morning,
Good
ma'am.
morning, ma'am.
Good
Good
morning.
morning, ma'am.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. Only 55 students have joined.
Good morning.
Good morning. So let's start. It is 25, so we cannot wait for more time. So last class we were discussing about entropy. So entropy is the measurement of degenerateness of a system, and already we have also discussed the entropy with a physical form of water, that is your ice, water, and water vapor. And you also you some of your friends and they have also explained how the entropy is less in ice because the molecules are restricted, means the motion is restricted in case of ice, and it is more in case of water, and again it is even more in the case of water vapor. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
First, so again, we also know that entropy is an important term in thermodynamics by which we can judge whether the thermodynamic process is spontaneous or non-spontaneous. Okay, so spontaneous means that have a natural tendency to occur in a single direction. Can you give one example of spontaneous reaction or spontaneous process?
Ma'am, can you repeat what you
Radioactivity.
said just now?
Can you give one example of spontaneous process?
Radioactive decay.
Radioactive decay is spontaneous process. Any other process? Spontaneous processes are reversible or irreversible.
Reversible.
Reversible,
Ma'am, irreversible.
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 Yes, ma'am.
And give one example of non-spontaneous process.
Melting of iron.
Melting of, what is that? Who can give one example of non-spontaneous
Ma'am,
process?
dissolution of common salt in water.
See, a process which is not takes place, which will not take place unless it is driven by an external energy or external input of energy, that is called a non-spontaneous process. Okay, so ice will melt spontaneously at room temperature, but if we'll put the ice in room temperature, can you like if the ice will melt to give you water in room temperature? Can you expect that if we'll put the water for a longer time in room temperature, will you get the ice from that? Unless until you are putting some external energy to make it ice?
No, ma'am. No, ma'am.
No. So if you can check, then all the spontaneous processes, like the reverse of the spontaneous processes, are non-spontaneous. If you think of ice to water is spontaneous, but water to ice is non-spontaneous because you are using the refrigerator, or you are putting external energy to make it ice. Am I correct?
Yes, ma'am.
Yes, ma'am.
Any background noise is coming from my side, or is
No,
it?
ma'am.
No, ma'am.
Otherwise, I'll switch off the fan. Okay. If I'm not able to do.
Ma'am, am I audible? Hello, ma'am.
Any of you want to tell me anything?
And Rishabh was speaking out something.
Rishabh, please tell me. Rishabh,
Just checking, ma'am. Ma'am, just checking, ma'am.
you are not audible. Please be louder. Rishabh, please be louder. I'm not able to hear you. Any of you could hear him? Then you can also tell me what he is telling. Okay, so maybe you will tell me after the class. Okay, so we were discussing entropy. So entropy change in a reversible process. So it is del S system plus Q by T because in a reversible isothermal process, you know what is isothermal means? The temperature is, there is no change in temperature. Constant process in which the system absorbs Q amount heat from the surrounding. At the same time, minus q by t. Any doubt up to this?
No, ma'am.
Ma'am,
Yes.
ma'am, what have you written? The surrounding also?
At the same time, the surrounding also loses the same quantity of heat at temperature T. So that is del S surrounding is equal to minus Q by T. Means it is absorbing, so that's why we are putting positive sign, and it is releasing, so that's why we are putting minus sign. Is it okay?
Yes, ma'am. Yes, ma'am.
Is it okay?
Yes, ma'am.
Yes.
Could you write?
Yes, ma'am. Yes, ma'am.
Then we'll discuss about entropy change from the surrounding. delta is system, it absorbs how much Q amount of heat
To
from
white.
the surrounding. So we'll write plus because it absorbs decrease in entropy of the surroundings temperature T2
What have you written before in entropy of the surroundings?
decrease. Actually, when I'm writing on the screen now,
Okay.
it is, it will think my handwriting is not good. And again on the screen it is washed. Okay, so just ask me, then I'll tell you what I have written. Total change in entropy delta surrounding increases in irreversible process.
मैम थोड़ा ऊपर कीजिएगा ना.
ठीक है.
यस मैम, थैंक यू मैम, हो गया. Ma'am, scroll the screen down.
Ma'am, why there are two temperatures taken?
What is that?
Why there are two temperatures taken? Temperatures.
Yes. T1 is the lower temperature, T2 is the higher temperature.
Okay. Ma'am.
In the first case, it was isothermal, but here it is not isothermal. Here temperature is varying. Is it fine?
Yes, ma'am.
Yes, ma'am.
So now we'll discuss entropy change accompanying an ideal gas. ये आप लोग ने पढ़ा था या नहीं?
No, ma'am.
No.
No, ma'am.
Okay. So in the case 1, we'll vary temperature and volume. Temperature and volume. So already we know that ds is equal to dq by t. So we can write that one du plus p dv by t. So that can be again written as du by t plus cv dt by t plus p by t dv. Plus it is equal to RT. So implies that P by T is equal to R by V. Can I write or not? Or any doubt up to this?
No, ma'am.
So now you just integrate. So now you will integrate by putting the limit, lower limit S1, higher
Ma'am,
limit.
can you go up once?
Where?
No, ma'am, the last one I finished writing. Thank you.
So based on this final expression, you will get some numericals in your exam. So just go through all the steps. If you have any doubt, please discuss with me.
मैम हम लोग का P बाय टी dv आगे जाके R dv बाय dt कैसे हुआ dv बाय dv R dv बाय v कैसे हुआ
ये लिखी हूँ ना यहाँ पे.
ओह हाँ 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 सॉरी
मैम मैम हेलो हेलो मैम आई एम हियरिंग माय वॉइस
Everybody completed?
यस मैम
So now temperature and pressure as variables. Which law? This one? P1 V1 by T1 is equal to P2 V2 by T2. Which law?
Boyle's law.
Boyle's law
Boyle's law?
शायद
Gas law, ideal gas law.
याद नहीं है.
श्योर नहीं मैम.
Charles and Boyle's combined
Combined gas law.
Combined.
Yes.
Ma'am,
Yes.
ma'am, in the first line you have written log P1 T1 by P2 T2.
Yes.
But
Oh,
ma'am,
oh, oh, oh. It should be P1 T2.
yes, ma'am.
Is it okay?
Yes,
Is
ma'am.
it okay?
Yes, ma'am.
Is it okay or any doubt?
No, ma'am. No, ma'am.
So let's solve some numericals based on these findings. And the last expression you have to remember.
Ma'am, last second step. Can you elaborate CV plus R?
What is that? Just I have taken common CV 2.303n log T2 by T2 by T1. This one and this one combined. I have taken common 2.303n log T2 by T1. I have taken common. So CB plus R we can also put together. Okay. So I have taken common 2.303n log T2 by T1.
Okay, ma'am.
Is it okay?
Yes, ma'am.
So 1 mole of an ideal gas expands against a constant external pressure of 1 atmosphere from a volume of 10 dmQ to a volume of 30 dmQ. Calculate the work done by the gas in joules. Can you solve it? Try to solve it.
Minus 2026.32 joules.
How much?
2026.32. Minus 2026.32.
Yes, correct. Minus 2026 joule.
Yes, ma'am.
Everybody got the same answer?
Yes, ma'am.
Yes, ma'am.
So this type of question, if you get in your examination, can you solve it? You may get this type of questions. This type of numericals you may get in your exam. So next question. Shall I solve or you have already solved? Everybody solve it, or if you are, any of you are not able to understand, then I'll solve now.
Ma'am, I'm not able to solve.
Same here, ma'am.
Same here, ma'am.
Yes, ma'am.
Okay, no problem. So you know W is equal to minus P dV so minus P V2 minus V1 what is the volume? It was 30 dmQ minus 10 dmQ. R is equal to 8.314 joule per Kelvin. So in dmQ, the value is 0.082 dmQ atmosphere. So the gas constant value in this unit, Kelvin inverse, mole inverse. Okay. So now you can calculate W in the form of joule. Can you do now?
मैम कर ही दीजिए, इतना कर ही दी है आप.
look, you have to just multiply 20 with this one.
Q, ma'am.
QQ1 atmosphere is equal to 8.314 joule per Kelvin per mole. That is equal to 0. Sorry, that is equal to 0.082. Okay. So W is equal to minus 20 dmq. So that is equal to minus 20 into how much you will multiply?
Ma'am, 8.314 divided by 0.082. And 202 minus 2026.32 joules.
Minus 2026.
Yes, 0.32 divided.
Also that much you just ignore. Is it okay?
Ma'am, in the examination, we will ignore the decimal point.
You will ignore?
Ma'am, decimal means that 0.32 or we will just round up the number.
Round up the number. I'll check and accordingly I'll give you the marks if everything is correct. Because here like in your board, the examiner is the question setter, they are different. But here the same person will teach you, set the question and take the examination. I may not set the question, but few of the faculty members, they will set the question, but they will definitely take my opinion, what I have taught in my class. Okay, so if you have done correctly, and again after checking the after examining your answer scripts, we will also inform you. There will be one day, I think 24 hours or something like that. We will give you time to check your answer scripts again after where you are thinking that you have not cut your marks and you have done it correctly. Then also you can claim to your class teacher. Okay, so the system is very transparent. If you have written and you have done it correctly, definitely you will get your marks. Is it okay?
Yes, ma'am.
Let's try to solve another one question. Why few students are not joining? Okay, try to solve this question.
Minus 213.
Ma'am, minus
minus
213 joule.
200
How much?
Minus 213 joule.
Minus?
213.
Okay. For everyone, you got the answer, same answer? I have to make a group. Actually, everybody has joined for the lab group. I think I have sent the link for the lab classes. I have sent the link for lab classes, isn't it?
No, ma'am.
No,
Yes, ma'am.
I have sent.
Yes, ma'am.
Yes, I have sent.
Ma'am, minus 213 joule.
Okay. Okay, for everybody, like I think all the students have solved this one.
Yes, ma'am. Yes, ma'am.
For everyone. If at least one student could not solve also, please let me know. Who could not solve? It is easy. Same way you can just like del u is equal to q plus w. So if you will just you will get the value of w, then you will put in the formula del u is equal to q plus w. So the u can be calculated. Okay. So all the students please join for the chemistry lab Monday. Okay, Monday I think already I think everybody got the link for the chemistry lab class and.
Ma'am, you're talking about the Google Classroom.
Yes. I'm talking about the Google Classroom.
Okay.
Yes, ma'am.
So that on that day only you have to join, just to because on Monday today our class after the class Monday again you have the lab class, so everybody has to join because all the students are present now. So I'm telling you to join, like to have the lab link. If anybody is not having, then you can write in the group so that I'll again send the link. Otherwise, you can
resend the link?
What is that?
Could you please resend the link?
Resend. Okay.
Ma'am, in the lab class, will join at 11 or 11:20?
When it is?
It is on 11:20, but last time sir told to join at 11.
And then you join at 11. No
Yes, ma'am.
problem.
Okay.
If you do not have any classes, then you should join.
Okay. ma'am.
B5 chemistry lab.